Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to have x plus 3 times x plus 5. For the math knowledge question, we have a square where one side is 12 meters long. Since it's a square, that means that the other side is 12 meters long. And it says a rectangle has the same area as the square. So the area of the square is 144. Our rectangle also has an area of 144, and it says that the length is 9 and the width we don't know. Well, all we need to do is 9 times the width has to equal 144. So if you do 144 divided by 9, you get 16 for your W. So that would be your width. So we are looking at lesson 15 today. We're going to look at interval notation, products of linear factors, tangents, and then increasing and decreasing functions. So the interval notation, if you took me last year, we didn't deal with it in pre-calculus, but some other pre-calculus textbooks do deal with interval notation, so you may be familiar with that. Products of linear factors, and then we're going to do tangents. You should have dealt with that a little bit in geometry, and then increasing and decreasing functions is kind of dealing with slope a little bit. Each of these designates an interval on the set of real numbers. This one right here, -3 is less than, but not equal to, because it's an open circle, less than x, less than 2, not equal to, because it's an open circle. Over here, -3 is less than or equal to x, which is less than or equal to 2. And then you can have a mixture where one is an open and one is a closed circle. Hopefully you remember that from Algebra 2. In calculus, we use interval notation because it's more compact than the notion that is here, than the notation that they have written here. So the interval notation for this is going to be -3, 2. We started at -3 and we ended at 2. It's in parentheses because they are open circles. We do not include -3 and 2. Over here, the interval notation would be -3, 2 with brackets around it. And the reason it's brackets is because they are closed circles. Over here on the left, does anyone want to take a guess as to what it would be? It's going to be open parentheses, -3, comma 2, and then a bracket to close it out, because it's not including 3, but it is including 2. Okay, for this next one, any ideas? It's going to be bracket, -3, comma 2, and parentheses. So those are the 4 interval notations for that one. For infinity, anytime you use infinity, you're always going to have a parentheses. So if you're saying -infinity to infinity, you're always going to do parentheses. You'll never have brackets with infinity because you can't include infinity because it's just a concept. It's not an actual number. So there's no way for you to include it. Okay? So that's what I just wrote out underneath each one. So infinity is not a number, it's just a concept. It's a word that we use to designate a quantity that increases without bound. So obviously you can't ever count to infinity because it just continues increasing. You can count you can always count higher than whatever number you're on. You'll never actually reach infinity. So infinity is just a concept. We use it to designate that it goes on forever, into eternity. Can't actually find infinity. So again, when infinity is used in interval notation, it's always preceded or followed by parentheses. So if you have infinity, you're always going to use the parentheses. You're always going to use that parentheses. You can use a bracket and one parentheses, or you can use two parentheses here with positive infinity, and then a bracket, and then your positive infinity. But you're never going to use, you will never see this. That cannot work. Okay? So we want to designate the following intervals by using interval notation. So y'all pause the video and y'all try the three by yourself. Y'all can discuss amongst yourselves and then unpause it and I'll show you what you do. So for this first one, our numbers, we're going to go from 4 to 30. So we're going to have 4 and 30. Now it's not including 4 because it's not or equal to. So when that doesn't include a number, we always do a parentheses. However, it is including 30. So we do a bracket. So that's your answer for A. For B, we are going from 22 to what number? They only give us 22, but what is the other number that we're going to? X is greater than 22, so we're going to go from 22 to positive infinity. Now, it does include 22 because it's or equal to, so we do a bracket. But with infinity, we never do brackets. We always do parentheses. So that would be your answer for B. For part C, our numbers are negative 42 and what? X is less than negative 42. So we're going all the way down to negative infinity. So those are our two numbers. Again, with infinity, you never use a bracket. And then on this one, it's not or equal to negative 42, so we do a parentheses because we don't want to include negative 42. So that's how you do interval notation. Hopefully, as you practice, it'll get a little bit more natural. It's not a terribly difficult concept. You just have to remember the rules. All right, so on which intervals is this function positive? So we're going to practice interval notation, and we're going to try and figure out where a function is positive. Does anybody know where the function is positive? Hopefully you're saying when it is above the x-axis, okay, whenever our y values are positive. So that would be here, here, and here, okay? So this interval notation, we're going to be coming from negative infinity to negative 8. So negative infinity to negative 8, and we're going to do open parentheses for negative infinity because we always do a parentheses with infinity. Now for negative 8, some of y'all may think you want to do brackets, some of y'all may think you do parentheses. Once we hit negative 8, is it positive? It's on the x-axis. So it's equal to 0, which is technically neither positive nor negative. So we have to do a parentheses because once we get to 8, it's no longer positive. All the way up to 8 it's positive, but once we hit negative 8, it is no longer positive. So that's why we have a parentheses. So now these are going by 2, so this is negative 4, and then we go to 4. So our numbers are negative 4 and 4. Are we going to do brackets or parentheses? Hopefully you're saying parentheses. Why are we going to do parentheses here? At negative 4 and at 4, it's 0. It's not positive yet. Once we get just above negative 4 and just below positive 4, it's positive. So that's when we do the parentheses. So for the last one, hopefully you think it is open parentheses, 8, comma, infinity, open parentheses. So those are the intervals where it is positive. Now looking at products of linear factors. So we're going to use a number line and interval notation to show where this function is positive and where this function is negative. So what you want to do is graph a number line like this. And then we need to put some numbers on there. And the numbers that we're going to put come from this function here. We need to know where our zeros are. So if you remember from pre-calculus, x is equal to 0 there. X equals -3 from this one. You basically set each of your factors equal to 0. X would equal -6. X would equal +2. And x would equal +5. Those are our zeros, where it's going to be changing. This function is going to look something like this. Or it could go like that, just depending on how many what the exponent would be. 1, 2, 3, 4, 5, x to the 5th, so it would have been this one. Well, actually, yeah, it would look like that. Alright, so let's start with -6. Well, let's do -7 because we need to be to the right of -6. I mean to the left of -6. I didn't put enough spots. Okay, so there we go. Everywhere you have a 0, you're going to go ahead and put a vertical line. Well, that wasn't so great. Okay, so this is going to be your answer, or part of your answer. We also are going to have the intervals. Alright, so we know that we're going to be positive or negative somewhere. So the easiest way is just to pick a number, not one of these numbers. I'm going to pick 1, and so this would be 1, this would be 4, this would be 7, 1 minus 2 would be -1, and 1 minus 4 would be 1 minus 5 would be -4. And if you multiply those together, we don't care what the number is, we just care if it's positive or negative. So positive, positive, 2 negatives make it positive. So in this interval, it's going to be positive. And that's how you notate that. And then it's going to switch. So it's going to go negative for this interval, and then it's going to go back to positive for that interval. Over here, it's going to be negative, and then it's going to be positive, and then here it's going to be negative. So that would be using the number line to show where it's positive and where it's negative. Now to use interval notation. So it's going to be positive here. That's from -6 to -3. Do we do parentheses or brackets here? We're going to do parentheses because, again, we don't include -6 or -3. It's also positive from 0 to 2. And you're going to do parentheses, 0 to parentheses. And then it's positive from 5 to infinity. So those are the positive intervals. Where is it going to be negative? Well, starting to the left, from -infinity all the way to -6. Again, you use parentheses when you use an infinity. So -infinity to -6. It's also negative from -3 to 0. And it's negative from 2 to 5. And so that would be how you show where that function is positive and negative. Now moving on to tangents. Hopefully you talked about tangents in geometry. We're not talking about sine, cosine, and tangent. This is a different math term for tangent. So in geometry, that would be a tangent line where it touches it at one spot there. It's coming from the Latin word tangere. I don't know if that's how you say it or not. They don't really know for Latin words because no one speaks it anymore. But this Latin word means to touch. It's a verb, and it means to touch. And so our line touches our circle at one spot only. That's what tangent means. Hopefully that is not a new concept to you. So a tangent is a curve, no, a tangent to a curve is a straight line that touches the curve. So if we have a curve here, and we want to touch it right here, this would be our tangent line. It's going to touch it in one spot right there. So you can make a tangent line to something other than just a circle. The slope of the curve at a particular point is just the slope of the tangent line at that point. So if you look here, if we want to know what the slope right here is, we just need to figure out what the slope of that tangent line is. And that would tell you at this x value, let's say it's 2, that's our x equals 2, and we want to know what the slope of the curve is at that particular point, we find the tangent line. Now, if I move to this point and I make it 2.5, it's going to have a different tangent line. That may not be exactly tangent, but it's going to have a different slope because it's going to be curving a little bit differently. And so that's okay. We'll deal with that a little bit more, but just know that it's only at a particular point what the curve slope would be. So if you look, line M is tangent at point P. And so if we wanted to find what the slope at point P was, we'd find the slope of line M. This line N is tangent at Q, but notice that it does, if we continue it, it does cross through R and S, and that is okay. We are just going to be looking right around here. So don't worry about if you continue it, oh no, it's going to touch the curve at more than one spot. That is completely okay. We're just concerned about right around our particular point we were looking at. So what values of x does this curve have a slope of 0? So they already drew one for you right here. The slope of 0 is when you have a vertical line. So we're wanting to know when our tangent lines would be 0. So at 8, also, if we drew a tangent line here at 2, and if we drew one at 16, well, I didn't draw that one so well. It would have a slope of 0. Y'all see any others? Hopefully you're thinking maybe 6. It does have a slope of 0 if we draw the tangent line. And also at 12. Those would be the 5 values of x where you have a slope of 0. Now looking at increasing and decreasing functions. So if you have a function that is increasing on your interval from a to b, then every input that you have every input that you take of x as it gets bigger and bigger and bigger should produce a larger and larger output value. If it is decreasing on the interval, every input that you make of x that gets bigger and bigger and bigger is going to produce a smaller output for your function. And so if you look here, this is where it is increasing. And this is where it is decreasing. So if it has a positive slope, it's increasing. If it has a negative slope, it's decreasing. And that's all you're looking at right now, increasing and decreasing. So looking here, on which intervals does it appear to be decreasing? So if we look, right now, we are going up. We are increasing. Think about a roller coaster. Where is your stomach going to start dropping? Once you go from here down. So that would be where it is decreasing. But here, you're increasing, 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 increasing. But once you get to this point, you start decreasing. And then again, we're increasing here, and we decreased all of that. So the intervals, that would be from B to C. How are we going to write that? Open parentheses, B, comma, C. Open parentheses, D, comma, E. Open parentheses, F, comma, G. Why do we do open parentheses and not close parentheses? Because at B, at C, at D, at E, F, and G, it's not increasing or decreasing. If I drew a tangent line here, it would be a slope of 0. You can't actually draw tangent lines here, here, or here, but it's the same concept, that it's neither decreasing nor increasing at those exact points. Okay, so now we're going to use a graphing calculator to estimate the intervals over which the function appears to be increasing. So grab your graphing calculator, and you're going to go to y equals, and you're going to do your function x plus 3, x plus 6, x minus 2, x minus 5. And then you're going to graph it. And what do you notice? It should be looking more something like that. But all we are seeing are the parts that are right here. We're seeing the straight lines. So we need to go to Window, and we don't need to change our x values, because if you look at it, it looks like we have all of the parts we need. We need to change our y values. So I'm going to go to negative 50 and positive 50, and I'll go by tens. And let's see what that looks like. Okay, so that's a little bit better, but are we getting the top and bottom parts, our max mins? No, so we need to go to Window, and we need to change it. Let's try negative 100 and positive 100. Okay, that's a little bit better, but you're still not getting enough of it. We need to go down further, and we need to go up further. But there's almost the whole peak right there. So let's try negative 200. And some of you may get better at guessing these. You may be able to do them a little bit more quickly. Hopefully, as you practice, you'll kind of know, okay, I need to jump more. Okay, so we have that one, but we still don't have the rest of the graph. So we need to keep going. So I'm going to try negative 400 and positive 400. And I'll go by 40s. Okay. Well, we still don't have all of it. So let's try negative 600 and 600. And we'll go by 60. Okay, we have almost all of it. We've got that one. We still need the top one. So we need to raise our y max. We don't need to worry about our y min. So I'm going to go to 700. And there's the whole graph. So sometimes you'll have to play with your window to get your graph to look like it needs to. But there's our graph. So now we need to figure out where it's increasing. So if you look on your calculator, it's increasing from down here. It keeps going up, 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 but it stops increasing right here. And then it starts decreasing, and then it starts increasing from here to here, and then it decreases, and then it increases from here to here. So we have 3 intervals where it's going to increase. So we need to figure out what this value is. And so the way that you do that is to go to Calculate, Second, and Calc. And we're looking for the maximum. So hit 4. And the maximum we know occurs right about there. So if we go to the left of the maximum, you hit Enter, and then go to the right of the maximum, and you hit Enter, and we guess that it's about right there. And it tells us the maximum is actually negative 4.9555. Okay, so we're going to come over here and we're going to do from negative infinity to negative 4.9555. And we're going to do parentheses on both because we don't include either number. Because once we get to this number here, it's no longer increasing. It's at 0. Then we're going to have to do calculate again. So we're going to do, let me go back to the graph. We're looking for this low point here. So that's going to be a minimum. So we're going to do calculate. We're going to do minimum. So let's go to the left of our minimum. And then you want to go to the right of your minimum. If you want to move your guess, you can. You don't have to. But there's your minimum. Negative 1.7055. Negative 1.7055. And it's parentheses because you don't include that number. And then where does it stop increasing? At this maximum. So y'all try yourself with the calculator to see if you can get it. You go to calculate. You go to maximum. You need to be to the left of the maximum and then to the right of it. And you don't have to make it guess. You can just hit enter. And it says it's 1.0663. And then we've got one more interval where it appears to be increasing from this low point. So what are we going to do on calculate for that one? You're going to do 3, which is your minimum. So go to the left of your minimum and then go to the right of it. And it gives you 3.9947. And then where did it stop increasing? It increases up to positive infinity. So we're going to go all the way to positive infinity. So those are your intervals where it appears to be increasing. So that's how you can use your calculator to help you find the increasing and decreasing parts. Your homework tonight is 1 through 25, so make sure to do those, and then we can go over any questions you have tomorrow.